Understanding network and its protocol is most crucial before breaking into system. You should know what you're doing before you do. Network protocols are a set of rules and conventions that define how data is exchanged over a network. These protocols govern communication between devices, ensuring they can understand and respond to each other. In this video, I'm going to tell you about the 15 network protocol that you must know as an ethical hacker. SSH is like calling a friend to provide remote help to fix something at your home. Instead of them physically being there, you give them access to your home security system and they can control everything from a distance, but with the assurance that no one else can listen in. SSH is a secure protocol used to access and manage network devices and systems remotely. It encrypts the data to ensure privacy and allows system administrators to execute commands on remote machines securely. SSH operates on port 22 and is used for secure remote login and command execution. It is commonly used by system administrators to manage servers, transfer files securely, or create tunnels for other network services. SSH is secure, but weak password policies or unsecured private keys can lead to unauthorized access. Additionally, if outdated cryptographic algorithms are used, attackers might exploit vulnerabilities to break the encryption. DNS is like a phone book for the internet. When you want to reach someone by name, you look them up in the phone book to find their phone number. Similarly, DNS maps a website's human-readable domain name to its corresponding IP address. DNS translates domain names into IP addresses, enabling browsers to find and connect to web servers. It works as a directory system that allows users to navigate the internet using easy-to-remember names rather than IP addresses. DNS operates over port 53 and is used by every device connected to the internet to resolve domain names. It allows users to access websites, email servers, and other network resources by mapping human-readable domain names to machine-readable IP addresses. DNS is vulnerable to attacks like DNS spoofing, where attackers manipulate the DNS records to redirect users to malicious websites. If DNS queries are not encrypted, they can also be intercepted and manipulated by attackers, which is why DNS over HTTPS or DNS over TLS are recommended for added security. DHCP is like getting a parking spot assigned automatically when you enter a parking lot. You don't have to manually choose a spot. The system assigns one to you based on availability. Similarly, DHCP automatically assigns an IP address to a device when it joins a network. DHCP is used to dynamically assign IP addresses to devices on a network. It simplifies network management by automatically assigning and renewing IP addresses, reducing the need for manual configuration. DHCP typically operates over port 67 for requests and port 68 for replies. It allows devices like computers, phones, and printers to obtain network configurations automatically when they join the network. DHCP is vulnerable to attacks like DHCP spoofing, where a rogue server can provide malicious configuration information to clients. Attackers can also cause network disruptions by flooding the network with fake DHCP requests, leading to denial of service. POP3 is like going to your postbox, collecting your letters and taking them home. After you collect them, you no longer keep them at the post office. They are only available in your home. POP3 is used by email clients to download emails from a server. Once emails are downloaded, they are removed from the server and stored locally, so the email is only accessible on the device that downloaded it. POP3 typically uses port 110 and is used to retrieve email from a server. It downloads messages to the client's device, which may remove them from the server depending on settings. This is useful for offline email access, but limits access across multiple devices. POP3 transmits data in plain text, including login credentials, which makes it vulnerable to interception. If email content or credentials are intercepted, attackers can gain unauthorized access to the account. IMAP is like accessing your mail from a post office where the letters remain at the post office. Every time you check your mail, you can read and organize it without removing it from the post office, and the changes are reflected across all locations you access it from. IMAP is used to access emails stored on a server, and unlike POP3, it keeps emails on the server. This allows for better synchronization across devices, as any actions are reflected across all devices accessing the same account. IMAP operates over port 143 or port 993. It enables users to access and manage their emails from multiple devices, as the emails remain on the server and actions are synchronized in real time. IMAP can expose email data if not secured with SSL or TLS encryption. Without encryption, credentials and email content are vulnerable to interception. Additionally, weak authentication or improper server configurations can lead to unauthorized access. SMTP is like a postman who collects your letter from your mailbox and delivers it to the recipient's address. It's responsible for the delivery of your message to the correct destination, but doesn't handle receiving it. Other systems take care of that. SMTP is used for sending emails from one server to another. It defines how email messages are routed and delivered across the internet, making sure they reach the recipient's email server. SMTP typically operates over port 25 or port 587. It is used to send outgoing mail from an email client to the mail server, or from one mail server to another for delivery. SMTP lacks encryption by default, making it vulnerable to interception. Attackers can spoof email addresses and send phishing emails or spam. If not secured with encryption, sensitive email contents and credentials are at risk. Telnet is like having a conversation over an open phone line without any privacy. Anyone who listens in can hear everything you're saying, making it insecure for confidential communications. Telnet is a text-based protocol used for accessing remote systems. It allows users to log into a remote computer or network device and interact with it via a command line interface. Telnet operates on port 23 and is used for remote system administration or troubleshooting network devices. However, it lacks encryption, making it unsuitable for secure use in modern networks. Telnet sends data in plain text, meaning attackers can intercept sensitive information, such as passwords and commands, using simple sniffing tools. This makes Telnet highly vulnerable to eavesdropping and man-in-the-middle attacks. SNMP is like checking the status of a factory's machines from a central control room. It allows managers to see how machines are performing, whether they're running smoothly or if they need maintenance. SNMP is used to monitor and manage network devices. It allows administrators to query devices for information like performance statistics, error logs, and status updates, making network management easier. SNMP operates on port 161 for requests and port 162 for notifications. It is widely used for monitoring network devices such as switches, routers, and servers by gathering performance and status information. SNMP can be vulnerable to unauthorized access if community strings or password are weak or exposed. Older versions of SNMP send data in plain text, making them vulnerable to eavesdropping and data manipulation. RDP is like a remote-controlled car. You sit at a distance and control the car using a remote, but the car's owner can see everything you're doing in real time. This is how RDP lets you control a remote computer as if you're physically present. RDP is a protocol used to access and control a remote computer's desktop interface. It provides users with a graphical interface for interacting with a computer from another location, as though they were sitting directly in front of it. RDP operates over port 3389 and is commonly used by IT professionals for remote administration of servers or by employees for remote access to their workstations. It allows remote graphical access to systems, facilitating troubleshooting and support. RDP is a frequent target for brute force attacks and can be compromised if strong passwords or multi-factor authentication are not used. Outdated versions of RDP have been exploited in vulnerabilities, making it crucial to patch systems regularly. Imagine you're sending a postcard with a message written on it. Anyone can read the message because there's no encryption. HTTP is the protocol used by web browsers and servers to communicate and transfer data like web pages. However, data transferred via HTTP is sent in plain text, which means anyone who intercepts the data can read it. It runs on port 80 by default. When you visit a non-secure website like an old blog, your browser connects to it using HTTP. The data is sent in plain text and anyone could potentially intercept it. For the solution of this problem, we have our second protocol, which is called HTTPS, or Hypertext Transfer Protocol Secure. Now imagine sending a sealed letter that only the recipient can open. The letter is protected by a security seal that ensures nobody can read it unless they have the key. HTTPS is the secure version of HTTP. It uses SSL and TLS encryption to encrypt data during transmission, ensuring that sensitive data is protected. It runs on port 443 by default. When you log into your bank account or make an online purchase, the website uses HTTPS to secure your personal data. LDAP is like an office directory. When someone calls the office to find out a person's contact details, the receptionist looks up the information in the directory and provides it. Similarly, LDAP helps find user or system data from a network directory. LDAP is used to access and maintain directory services. It is used for authenticating and retrieving information about users, groups, and other resources in a network directory, such as Active Directory in Microsoft environments. LDAP operates over port 389 or port 636. It is used for querying and modifying directory services and is often employed for user authentication and managing user rights within a network. Without encryption, LDAP communications can expose sensitive information to attackers. LDAP is also vulnerable to attacks like LDAP injection, where an attacker could manipulate queries to gain unauthorized access. NTP is like setting all clocks in a building to match the time displayed on a central clock. Every clock synchronizes to the correct time, ensuring consistency across the entire building. NTP is used to synchronize the time across all devices in a network. It ensures that every system in a network maintains the correct time, which is essential for accurate logging, scheduling, and security. NTP operates over port 123 and is used to synchronize system clocks with a reference time source such as an atomic clock or GPS signal. It ensures that time discrepancies between different devices do not cause issues with logs or time-sensitive processes. NTP is vulnerable to time manipulation attacks where attackers could skew the system clocks of affected devices, potentially breaking time-sensitive protocols or logging systems. NTP can also be exploited for DDoS amplification attacks, where small requests can cause large amounts of traffic to flood a target. FTP is like delivering a package to someone through a delivery service. You drop off the package at the post office, and the recipient picks it up at the other end. But the delivery doesn't come with any security, and anyone along the way can open the package to see what's inside. FTP is a standard network protocol used to transfer files from one machine to another over a TCP/IP network. It allows both the uploading and downloading of files, and provides commands to navigate file systems on remote servers. FTP typically uses port 21 for sending commands and port 20 for transferring data. It's commonly used for uploading content to a website or transferring large files between systems on a network. FTP transmits data, including usernames and passwords in plain text, making it vulnerable to interception and attacks like man-in-the-middle. It also has no built-in encryption, meaning sensitive information can be easily captured. SFTP is like sending a package with a lockbox inside the delivery truck. The package is delivered securely and only the recipient has the key to open it, ensuring that no one can tamper with it along the way. SFTP is a secure version of FTP that uses SSH to encrypt both the command and data channels. It provides secure file transfer capabilities, ensuring that data is protected during transit. SFTP runs over SSH, typically using port 22 for both command and data transfers. It is widely used for securely transferring files over the internet, particularly for sensitive data or corporate file exchanges. While SFTP encrypts data and credentials, weak passwords or poor key management can still expose systems to brute force attacks. Additionally, if SSH is misconfigured, it could lead to unauthorized access or other vulnerabilities. And that's a wrap on our deep dive into the top 15 network protocols. From the basics of HTTP to the complexities of secure communications like HTTPS, I hope you now have a clearer understanding of how these protocols power our digital world, along with the security risks to watch out for. If you found this video helpful, don't forget to hit the like button, subscribe to the channel, and ring the bell so you never miss an update. Got any questions or topics you'd like us to cover next? Drop them in the comments below. Stay safe online and I'll see you in the next one.